Now let's move to general properties from number 4 to number 10. And these properties here are chemical properties, chemical reactions. We're gonna study their behavior, okay, during chemical reaction. Okay, number 4, the effect of atmospheric air. All metals here can be oxidized easily in air and lose their metallic luster due to the formation of a layer of metal oxide. But only lithium can react with nitrogen gas from the atmospheric air, forming lithium nitride that dissolve in water, forming lithium hydroxide, and ammonia gas evolves. Okay? Here, elements like sodium must be kept under the surface of kerosene and inside a jar, as you can see here, because they are a very active element that can react with the humid air, the water in the humid air. Okay, and this is a very dangerous reaction. Number 5, reaction with water. Look here, the reaction with water. Here, metals of this group can react with water, forming metal hydroxide and hydrogen gas evolves. In addition, this reaction is exothermic, so it's a very dangerous reaction. Look here, for this equation, sodium plus water gives sodium hydroxide and hydrogen gas evolves plus heat energy. It's an exothermic reaction, so it's very dangerous reaction. And as we go down in this group, the danger of this reaction increases because the activity of metals increases, which means that this reaction with potassium is more dangerous than sodium, and with cesium it's the most dangerous ever. Okay, number 6, reaction of alkali metals with oxygen. Here, alkali metals reacts with oxygen to give us 3 types of oxide, according to the amount of oxygen. Normal oxide, peroxide, superoxide. In this direction, the amount of oxygen, the percentage of oxygen inside the oxide increases. So here, as you can see from the chemical equation, lithium plus oxygen, 180 degrees Celsius gives lithium oxide. This is a normal oxide. Its general formula, M2O. Peroxide here, like sodium plus oxygen, 300 degrees Celsius gives sodium peroxide, Na2O2, M2O2. This is the general formula. While potassium with oxygen, 300 degrees Celsius, gives potassium superoxide, general formula, MO2. So in this direction, the amount of oxygen increases. And the oxidation number in case of normal oxide, -2, peroxide -1, superoxide -0.5. Now, you have to know that peroxide and superoxides are compounds that acts like what? Strong oxidizing agents. Okay, because as you can see here from this equation, we have what? An extra amount of oxygen. So they are what? Strong oxidizing agents. In addition, potassium superoxide can be used to purify the atmosphere of closed areas like airplanes, submarines, because it reacts with carbon dioxide gas in the presence of copper chloride as a catalyst to give potassium carbonate and oxygen gas. So it takes carbon dioxide gas, giving us oxygen gas. Okay? In addition, you have to know that during the preparation of oxides of alkali metals, especially in the case of normal oxide, the alkali metals can be prepared by dissolving the metal first in a liquefied ammonia, then adding the calculated amount of oxygen, not directly. Okay?